On the 26th of October, NASA announced that they had found water on the sunlit surface of the moon. Now, this is obviously a massive discovery as it allows us to potentially come a little bit closer to creating a habitable base on the moon. Because of this discovery, I decided it'd be a perfect time to look at the science governing rockets. To understand how rockets work, we first need to understand Isaac Newton's 3 laws of motion. Now luckily, we've already got a video on that, which I will leave in a card above. So if you haven't seen that yet, or you don't understand how Isaac Newton's 3 laws of motion work, give that a watch and come back to us. We're going to combine Newton's 3 laws together to understand how they relate to rockets. Let's take a rocket that's on the ground, ready to take off. It's in a state of rest, as there are no external forces acting upon it. Now in order to leave this state of rest, an external force will need to act upon it, and this is Newton's first law of motion. The thrust of the rocket, or the force that propels the rocket into space, is generated when fuel is combusted within the engine. Now, combusted is just a fancy word for burning of fuel. When this happens, hot exhaust gas is accelerated through the rear of the rocket. This reduces a reaction force on the rocket and causes it to accelerate. This is Newton's third law of motion. The amount of thrust or force that is generated by the rocket is determined by the mass of rocket fuel burnt and how fast the gas exits the rocket. This is the second law of motion. So what do we use to propel rockets into space? Well, as I mentioned a little bit earlier, in order to launch a rocket, we need to burn fuel. And in order to burn fuel, we need an oxidizer. In this case, oxygen. Think of it like a candle. You have candles in glass jars with lids, and when you put the lid on the jar, the oxygen that's left in the jar is used up to burn the flame. But once all of that oxygen is used up, there's no more oxygen and the flame goes out. If there's no oxygen present, then combustion can't occur. For jet engines, this is fairly easy as oxygen is drawn into the engine from the surrounding air. But rockets don't have this luxury. Because they need to be usable in space where there is no air and no oxygen, we need to have all of the oxygen that we need for the burning of the fuel to be contained within the rocket during flight. And so the propellants are the rocket fuel and the oxidizer combined together. Most rocket propellants are either solid or liquid. In the case of solid rocket propellants, the propellants are usually a mixture of the fuel and oxidizer in a solid chemical. In this case, the fuel is usually a mixture of hydrogen or carbon compounds, and the oxidizer is usually oxygen compounds. To ignite solid propellants, we usually use an electrical circuit which surrounds the solid propellant. This is then heated up, which in turn causes the propellant to heat up to the point where it combusts. And then we have our working rocket. So rockets that use solid propellants are the simplest type of rocket engine that we have. An example of a rocket that used solid propellants is the space shuttle. Now, it didn't strictly use solid propellants in its own rocket, but the 2 booster rockets that we used to launch it into space had solid rocket propellants within them. In the case of rockets that have liquid propellants, the fuel and oxidizer are stored in separate storage tanks. Now, the fuel is usually kerosene or liquid hydrogen, and the oxidizer is usually liquid oxygen. Now, the fuel and oxidizer are combined within the combustion chamber where combustion occurs, and this causes hot exhaust gas to propel the rocket into space. And to ensure maximum efficiency of the mixing of these 2 liquids, we usually use injectors or pumps. And like I said, these just increase the efficiency of the mixing of the 2 liquids so that we can get the most efficient rocket possible. You can also make your own rocket at home, obviously not with liquid kerosene or solid rocket propellant, but with water. So I'm going to be doing a video very soon where we're going to make water bottle rockets. So keep your eyes peeled for that. So how heavy are rockets? Well, the mass of a rocket is really important to ensure that the launch is successful. According to NASA, an ideal rocket should have its mass distributed in the following way. 91% of the rocket's mass should be down to the propellants, so the oxidizers and the fuels. 3% of its mass should be due to the engines and the fins, and 6% of its mass should be its payload. So it's quite a small amount of the mass is actually the payload. An example for you, the Space Shuttle Discovery had a mass of around 2,051,113 kilograms, and its cost at launch was approximately $450 million per mission, and this is around £314 million per mission. So quite a lot of money to launch the Space Shuttle Discovery into space. So why does a rocket start really, really slow and get quicker and quicker and quicker as it climbs into space? Well, this can be explained by the second law of motion. If we look at a rocket, as I said, 91% of its mass is made up by its propellants. Now, these are being burnt throughout its flight. So the mass of the rocket is actually reducing throughout its climb into space. Looking at Newton's second law of motion, in order to keep the force constant, while the mass is decreasing, the acceleration must be increasing. So as it climbs into space, it's getting faster and faster because its acceleration is increasing. One other thing that we need to consider when launching a rocket into space is escape velocity. Now, escape velocity is defined as the minimum speed that something must achieve in order to overcome Earth's gravitational force, or overcome anything's gravitational force. On Earth, this is around 11 kilometers a second. Rockets leaving the Earth must reach this speed in order to overcome Earth's gravitational influence. The difference between launching a rocket from the Earth to other planets or moons is literally just the difference in this escape velocity. So if there is a stronger force of attraction on a different planet, then it would be harder to launch a rocket on a different planet or moon. If we look at our moon though, the escape velocity is around 2 kilometers a second. And so it's a little bit easier to launch a rocket from the moon, as long as you have obviously all of the propellants that you need to reach that speed and to make your way back to the Earth. One other cool thing about escape velocity is it's the reason that we can't see black holes. The escape velocity of a black hole is greater than that of the speed of light. And as a result, nothing can escape the gravitational influence of a black hole, not even light. And therefore we can't see it. I started off this video talking about the recent discovery of water on the sunlit surface of the moon. I just wanted to touch slightly on why this is cool and what it means for us in the future. Because we found water on the sunlit surface of the moon, the chances of us building a habitable base on the moon have increased. And so this could be something that could happen in the not too distant future. NASA have a program called the Artemis program, which will send the first woman to the moon and the next man to the moon by 2024. This program also aims to create sustainable exploration by the end of the decade. This could further influence space travel in the future, as it could allow us to make a pit stop on the moon on our way to places like Mars or other planets in the solar system. This could also have an impact on programs such as the Mars 1 program, which aims to set up a human colony on Mars by 2032. NASA also have a Moon to Mars program, which aims to prepare for a manned mission to Mars sometime in the not too distant future. So hopefully we won't have our own version of the Martian film, because as much as that had a happy ending, it was quite a journey for all of the characters involved in that film. I'll put links to all of these programs in the description below, by the way, so if you want to check out any of these programs like the Artemis program or the Moon to Mars program or the Mars 1 program, I'll leave links down below for you to read. As always, if you've enjoyed this video, please leave a like, comment and consider subscribing. I very much enjoyed making this video, and I hope you guys have enjoyed it too. I'm going to be releasing more science and tech videos every other Saturday on this channel, so make sure you keep an eye out for that. And also keep an eye out for our water rocket experiment video that's going to be coming up very soon. We're going to make water rockets, maybe Mento rockets. Not sure what other rockets we can make, but if you have any ideas, do leave a comment below and let me know what rocket you want me to try and build. But hopefully it'll be quite a fun video to watch as well. So keep an eye out for that one. But as always, I'll see you in the next one.